Pourquoi parlons-nous aujourd'hui des SBOM, donc des Software Bill of Material? Alors c'est lié d'une part sur ces dernières années à la forte augmentation de l'utilisation des composants open source dans les applications et les produits qui sont développés aujourd'hui. Et cette utilisation poussée amène certains challenges, défis qu'il faut traiter. Également sur ces dernières années, comme vous devez tous le savoir, il y a eu une explosion de la complexité et de la taille des logiciels qui amènent certaines contraintes dont les SBOM vont traiter. Et bien entendu, la connectivité a fait également là accroître le risque au niveau des attaques cyber. Et si on parle un petit peu plus de certains domaines d'activité, entre autres aujourd'hui le médical, il y a également des évolutions dans les réglementations, que ce soit au niveau US avec la FDA ou côté européen avec la nouvelle réglementation sur les devices médicaux, qui entraîne là aussi des activités à réaliser autour des logiciels et des SBOM. Alors qu'apportent les SBOM? Eh bien, je vais pour cela laisser la main à Rob Dalton qui va vous présenter tout cela. Je lui donne juste la main. Et Rob, it is up to you.
Well, hello everybody, and thanks very much for your time today. What I want to spend about 45 minutes on in this presentation is to look at the growing usage of open source software, but how that comes with increasing risks to those adopting it knowingly or indeed unknowingly, which we'll talk about later too. And then we'll look at what some of those risks are, and then look at the growing fight back that's underway, has been for a few years now, in the form of regulation and tooling. So in terms of an agenda, I just want to look at a definition of what open source software is, and then some statistics to show how it's being embraced. Everybody's loving it for some obvious reasons, but that open source comes with some challenges in the forms of, you know, exploits, license risk, and media attention, and we'll look at some of those topics. And then we'll move on, just understand what sort of tooling is available to you dependent on your use case and environment. And then we'll look at how to fight back through regulations, which will then lead on to talking and introducing what a software bill of materials is. And then we'll take a slightly closer look at a couple of medical standards that may be relevant and interesting to the audience. And then I'll conclude really with a CodeSentry presentation. So I'm sure you have a pretty good understanding of what open source software is, but I like this definition here from IBM because it clearly highlights the strengths of open source, but also its exploitable weaknesses, which I've underlined in red. It's the openness of open source, which is inherently means that it's more prone to unintended but also malicious vulnerabilities that can exist within it. Irrespective of those concerns, there are definite advantages to utilizing and relying on open source. And you know, here I just summarize some of that explosive growth. As you can see here on the large chart on the right, in 2020, we can see that just the GitHub repository had something like just over 50 million repositories in 2020, whereas in the updated 2024 statistics in the bottom left, you can see that that number's grown to 420 million. So genuine explosive growth there. And interestingly, in the 2024 metrics, we've also got a count of how many generative AI-based projects there are hosted on GitHub as well, which I always find an interesting new development, and certainly makes me think of a colleague of mine who is fond of saying AI is disarmingly confident at stating false information. So, another way of saying AI, great, but, not foolproof as yet. So what are the challenges of open source software? First off, there's just literally the difficulties of keeping track of where open source software is used in your applications that you may be developing. Of course, there's your custom code that you author, and clearly you're going to have very detailed understanding and clear understanding of that code. It's just what you author. There's no open source in that code, so no worries other than for the problems your developers introduce themselves. But then you may be relying on open source, as we've just been alluding to, but it's open source that you choose to directly rely on during your development. So hopefully you're aware of it, so you can track what the repercussions are of relying on open source that you directly utilize in your development. But then it starts to become a little more of a grey area to easily track that open source software. You may be using third-party libraries from commercial vendors, and those organizations themselves may be relying on open source code as well, which is what we refer to here as fourth-party code. And potentially, in the case of third-party code, the norm, the commercial norm, is to rely on binary-only variants of those components or libraries from those commercial vendors. And so it's not only is it invisible to you because it's binaries that you're relying on in your development, you don't know what they have relied on, and what basically transitive dependencies of other components are being relied on. So the picture becomes murkier the more that you get down this itemization of where code can come from. Then, factoring that in mind, you've then got to bear in mind in certainly some sectors, as with this example here in automotive, code bases are forever growing larger. Certainly in the automotive industry, there's been an explosion in the scale of a code base. It's often said that a modern car is software on wheels. And there's huge scope throughout all of those different systems, advanced systems, critical systems. Certainly that would be applicable terminology to the medical space as well, with the criticality of what's going on. These large code bases are just making it ever more difficult to track and follow what open source is going on and being used. And I like this little picture of an iceberg here as a nice metaphor for the reliance potentially on open source software and dependencies in your development. We only get to see the tip of the iceberg. In reality, the majority of the iceberg, 90% of it, is below the waterline, and it is invisible to us. It's only when we see pictures like this that we fully appreciate the scale of what we're looking at. And you can really see modern software development as having that sort of iceberg type status or structure. Yes, you're probably aware at the immediate source code level that you author, you're aware of the relationships and the dependencies and the details of what you're using to develop your code. But then beneath that, there's the tendrils of dependencies on dependencies on dependencies, and that becomes quite an unknown and therefore worrying truth about modern software development. So to go hand in hand with that explosion of open source components, we've also got the corresponding explosion of vulnerabilities, which are recorded in this case by the National Vulnerability Database. This is a snapshot taken this month, although the NVD only had metrics for through 2022. They've not updated to the latest metrics yet, but you can see the very clear trend from this chart that with the passage of time, there are more and more reports of confirmed vulnerabilities in open source software at different levels of criticality. All those criticality levels are increasing year on year. It's a very, it's just a fact of life that more open source is going to result in, an expected increase in vulnerabilities as well that exist in those suites. So besides all the vulnerabilities which potentially can be there in the open source, the majority of open source libraries also come with certain licenses that dictate how they can be used and deployed and so on. And this is certainly a piece of the open source puzzle that should not be ignored, because failure to adhere to the terms of those licenses that you fundamentally related to through usage of open source can have some severe impacts on your business if you don't do things correctly. And all of those problems can lead to potentially some embarrassing headlines finding their way into the media, and no organisation wants to be on the receiving end of unwanted media attention. And I could come back, and if I presented this presentation every week, I could easily find some new different headlines every week still to keep this slide updated and current with, stories about organisations that they'd rather not see posted there. And when I was researching this presentation originally last year for headlines to include, I was really surprised. It made me smile when I came across this particular headline, because the Log4j vulnerability was first reported at the end of 2021, and it had huge media attention at the time. And you would have expected or hoped the majority of organizations that might have had a dependency on the particular component that had this flaw would have done some due diligence. So I was, as I say, surprised to see this headline nearly 18 months after Log4j was first reported, that it was still being taken advantage of. We've sort of defined, the value of OSS, but looked at some of the risks inherent in utilizing OSS soft components and libraries. What can you do in terms of tooling to try and help you track and understand what open source software you may be reliant on? Well, it's first best or useful to understand the two main audiences for who may want to understand the dependencies in their environments. Producers and consumers. Producers obviously are referring to the organizations that develop software, so they typically have their own source code, and in that case the class of tool which is typically deployed is source code composition analysis, what we traditionally think of as SCA, okay, but it is better labelled today as a source code SCA, or at least be appreciative that SCA is related or referring to source code composition analysis. The reasons why SCA is preferable if you've got your own code is that source code is a more detailed repository for an SCA tool to track, examine and understand, and therefore know what potential open source components you may be reliant on. Of course, though, Source SCA starts to lose its effectiveness if you're using components in a binary-only form from suppliers to your development process, external third-party suppliers. And it's not also always easy to deploy Source SCA if you've got legacy software to still maintain, and potentially worry about regulations, which we'll talk about in a few minutes. So even in the producer use case, what I'm trying to get at is that there is scope to consider deploying the other class of composition analysis tool, which is binary composition analysis. And in fact, that leads on nicely to the consumer use case. We're all consumers of software, which we typically always consume in its binary-only form. Obviously, if you're worried about that binary software, source code composition analysis tools are pretty useless. They can't tell you anything about what the dependencies are in binaries. And so, as I say, in that scenario, you're going to need to rely on a binary composition analysis tool, which ultimately is the product which I'm going to demonstrate to you in a few minutes. So, how is industry and national governments fighting back against the growing problems that are there because of open source software? Well, really what I want to summarize through this particular slide is a sampling of some of the regulations that exist today, both nationally, and across industries. And much like my media headlines earlier, if I was to recreate this slide next week, next month, next year, it would be a moving target. There is a growing number of regulations springing up around the world that are mandating or recommending how secure cyber resilience processes and procedures and documentation should be followed and produced if you're consuming, developing software in different nationalities or industries. Gartner, who I'm sure you've heard of, they believe that by 2025, irrespective of whether you think you need to worry about building bills of materials or not, they expect that by 2025, so next year, 60% of organizations are going to be mandated to produce SBOMs through one standard or another, which is quite an increase from the 20% of organizations which were doing it back in 2022. So what is a software bill of materials? Well, it's just an inventory predominantly of the components that you rely on in a piece of software. And the US's National Telecommunications and Information Administration were one of the first major organizations to try and formally define what an SBOM should look like, what it should contain, how it should be used, so on and so forth. And really there were three requirements that they defined, and the first two were sort of the key ones that they felt needed to be delivered on for SBOM content or generation. And the first one was obviously, I suppose, what the data field should be that should exist in a bill of materials. And it was obvious things such as, you know, what the supplier of a component is, the component name, the version, other unique identifiers about those components, the author of the SBOM, and the timestamp that it was created. Additionally, in terms of automation support, they said it makes sure that the reports or the documentation that the form of the SBOMs needs to be in a format that can be easily ingested by other tooling, so can be automatically manipulated by tool chains in organizations' environments. So leading on from that lead from the NTIA, we had some early movers in terms of what SBOM formats should be suggested. We've got 3 here, certainly a couple that have seem to be getting widely adopted is the SPDX SBOM format, which was developed by the Linux Foundation, and the Cyclone DX format, which was developed by the OWASP organization. These are the formats which, certainly in my experience over recent years, it's one of these 2 which organizations are looking to be able to produce or consume. So just before I go on to my presentation of CodeSentry here, our binary composition analysis tool, I just want to briefly look in summary at a couple of medical regulations that exist out there, which you guys may find yourself needing to be aware of and considering in your development of software that, well, software and hardware actually, that you may be looking to sell in different jurisdictions. So firstly, we've got the IEC's 81001 regulation, which is a standard dedicated to medical device cybersecurity. And it plays a role in what the requirements for development and maintenance of health software is if you're looking to follow another standard, IEC 62443. The key takeaway if you're having to follow 81001 is that it requires a software bill of materials be delivered as part of your cybersecurity management process. And 8001 is expected to actually become the harmonized standard, replacing another current pair of standards, MDR and IVDR, medical device regulation, and the in vitro diagnostic medical device regulations. But even those 2 standards as they stand today highly recommends that a software bill of materials should be developed if you're using software of unknown provenance or open source software. And also, interestingly, strongly recommends that you perform vulnerability scanning as well. So, what does the FDA look for in an SBOM submission? I mean, obvious and common sense requirements here, and I won't necessarily go and read the slide contents for you, but we'll see many of these requirements in my CodeSentry demo, which I'm about to show you. CodeSentry isn't written to be a tool to produce FDA compliant bills of materials or reports, but it's just common sense requirements of the FDA for SBOMs that are equivalent features and capabilities, as you'll see in my demonstration in a moment. Okay, so let me move on to my CodeSentry demonstration. Just a reminder, if there are any questions, please put them in the meeting chat, and Fred will bring those to my attention and I can answer them either during the demo about the presentation, or we can answer some questions at the end. So let me go into CodeSentry. So CodeSentry is our binary composition analysis tool. And the flavor of it, which I'm showing you here, is our SaaS instance. We've got a couple of basic flavors. There's an on-premise deployment of CodeSentry if you are worried about releasing your software out into the internet, of course. or there's the much easier to use SAS variant, which I'm demonstrating here. Now, CodeSentry is a really straightforward tool to use, and it's predominantly a one-screen tool, the screen that you're seeing here. The majority of the screen is reserved for studying the results of scans. Down the left-hand column here, we have a number of scans which we've already performed on different target artifacts. And finally, most importantly, here, how would you go about producing or performing a new scan? Well, you have to provide some simplistic, obvious data, such as what the name of the parent folder is, what the name of the scan is, and what sort of optional scans you want to perform. In the interest of time, I'm not going to go into the details of all of the different types of scans that CodeSentry can perform. The key capability that CodeSentry provides is its binary composition analysis scan, which is always going to be performed. These other three types of scans are optional, as you can see from here. The final information that you would then need to provide is obviously the thing that you want to scan, the artifact that you want to scan. The artifact can be individual binaries, or it can be archives of multiple different binaries. And we're able to consume binaries from numerous different language origins. So not just compiled binaries, but the binaries can be from Java or C# or Python, JavaScript, Rust, a whole host of other origins that those binaries originated from. But ultimately, CodeSentry is always a binary analysis tool. And in terms of archives as well, it's the obvious archives such as zips and tars and things like that, but also deployment archive types like MSI files or ISO images, so on and so forth. A huge range of things can be immediately scanned out of the box, as it were, by CodeSentry. So once you've populated this dialog, you would click Start Scan. The thing which you wanted to be scanned would be uploaded to CodeSentry, be it in the cloud or your on-prem installation, and CodeSentry would do its scanning and ultimately produce you some results, some of which we're seeing here on this view. I've done a scan here of an open source piece of video editing software called Camtasia. And we can see in the Bill of Materials tab an itemization of the uniquely detected components that existed within Camtasia. Okay, and by unique I mean a tuple of individual attributes, the name of the component, the version of that component, and the provider or the vendor of that component. So for instance, libxml2 is reported twice here, but it's reported twice because it's a version of that library which comes from two different vendors or different versions of libxml which have been discovered in the code base. At the top here is some summary statistics. Because for this scan of Camtasia, I performed not just the binary composition analysis to find what components were in Camtasia, I also performed the security attributes and a zero-day findings scan. And if anyone's interested at the end, please ask me and I can potentially just define a little more what those two capabilities are, but I am aware of time here, so I'm just focusing on the key capability of CodeSentry. But those summary stats there give us an overall view of the quantity of vulnerabilities or CVEs which have been in total found in these different severity categories. And we get an overall percentage coverage of how many targets within the artifact which was scanned had no known vulnerabilities with them. To make that a little clear, what I scanned here was an archive. It was an MSI file. If we go over to the Scan Status tab, we can see that CodeSentry unpacked that MSI file and saw that there was in total over 6,000 individual elements within there, binaries, text files, image files, so on and so forth. A great many of those items could be skipped because they weren't viable binaries, they weren't DLLs, they weren't executables, for example. They were text files or image files which we're not interested in scanning at all. All the same, there were still many things that needed to be considered and scanned, which then ultimately comprises the results that we see summarized above here. The key takeaway I like from this particular view is that a typical piece of software isn't an individual binary these days. It's a suite of necessary components itself, binaries, DLLs, and the things that I've itemized already. And there's a lot of elements that need to be individually assessed and understood to see what dependencies each of those have. So, as I said, in the Bill of Materials tab, we're itemizing the results that we found. If I go down to the OpenSSL row here, I can see actually there were two instances of OpenSSL 102 discovered. One was in this particular DLL here, and another one was in this other file within the archive. You can see the full path given here through the archive here. We had a high degree of match confidence, which I'll explain in a moment, for deciding that OpenSSL 102 was being depended on by these two targets. And then moving further along, we give an itemization of the vulnerabilities that are known to afflict OpenSSL 102 through different severity categories. Further along the row, we tell you what open source licenses are required if you wish to rely on OpenSSL 102 in this case. And then further along, we give you the evidence which we lifted during the scan of this DLL or that DLL, what the evidence was that we lifted and then used to conclude that OpenSSL 102 really had been used. And as you can see, we rely on a number of different techniques for extracting information or data from the target binary being scanned. And in this particular case, in this particular result, we predominantly relied on strings which we extracted from the binary. Over 1,000 unique strings were usefully extracted in the conclusion that OpenSSL 102 was being used here. For instance, this is one of the strings which we found in this target binary, and it was used 17 times. And in the OpenSSL 102 repository, this particular string is actually used in each of these source files at each of these line numbers. So all of this evidence, you can see all of these strings itemized here, was all used in drawing the conclusion, again, that OpenSSL 102 really was used in the development of this DLL. What's the confidence level or the match column indicating? Well, literally how confident CodeSentry is about the claimed component result here. And you can get high, medium and low confidence levels. Why can that be? Different confidence levels? Well, one of the key factors is to do with the amount of signal or data that we extract and then use to arrive at these conclusions. If in the development of a particular binary, a OpenSSL, for example, was only lightly used, only a couple of API calls, for example, were made, then clearly there would be less residual evidence of the OpenSSL library tucked away in the binary being scanned. And that can therefore mean a low confidence result, just because of the small amount of data that was used to arrive at that conclusion. Doesn't mean the result's wrong because it's low confidence, but on the other hand, if we find a really large amount of evidence which would correlate perhaps with a high usage of API calls into OpenSSL, then obviously that follows that lots of evidence that we end up matching to a component can lead to CodeSentry concluding that we can be very confident or have a high confidence that we've really found that component. You're able to annotate the findings here. In other words, if you decide that a result of a component is uninteresting or false, then you can choose to annotate away individually or globally all of those results for OpenSSL, and from there you can choose to whether to include that component or exclude that component from the final bill of materials reports that we will generate, and you can have a comment that you can make here as well. So you'll see already that I have expanded the particular row here to do with this usage of OpenSSL, and when we do that, we're taken to a view of the individual identifiers for the vulnerabilities which exist across the different severity categories here. And the reason why we have these two sets of identifiers is because CodeSentry relies on two sources of vulnerability information to explain what known vulnerabilities there are. We originally relied on the National Vulnerability Database set, but whilst that was a good starting point, it's not a commercially maintained data set. So a reasonable amount of time now, CodeSentry incorporated a commercial data set from an organization called Risk-Based Security. And it's a much richer data set, many more vulnerabilities. It's more actively maintained and kept accurate, for example, and has additional interesting fields of data and metrics which can be used in the later assessment of vulnerabilities, as I will move on to in a moment. But one interesting fact I can lift from this data already is the IDs here, which are hyperlinks. I'm not going to click on them, but they're hyperlinks through to the information that the National Vulnerability Database maintains on this vulnerability. You can see that the year is encoded in the link, and you can see that some of these vulnerabilities that have afflicted OpenSSL 102 were reported a really long time ago now. So immediately I can start to already draw some conclusions that perhaps the authors of Camtasia are less focused on cybersecurity risk and perhaps are more focused on product features and enhancements. So I can take from here any of these vulnerabilities and go and focus a little bit more on what they mean by moving over to the End-Day Findings tab, where there's a whole collection of fields that I can use to filter and sort results by. But if I were to go and put in the ID which I collected here, CodeSentry will update with the components that are found to have a reliance on a flavor of OpenSSL which has this particular vulnerability within it. And actually you can see amongst all the components we've got not only OpenSSL 102 results, but also it transpires that OpenSSL 101E suffered from this vulnerability as well. So from this page I can delve into the detail of the vulnerability, and if I scroll down a little bit, we've got a whole rich source of Wikipedia-like information which you can read to understand everything you would ever need to know about this vulnerability. I will leave you at your discretion to delve into that information, because the key information is summarized in these 4 color-coded boxes. Color is used to give you an instant sense of how much attention you should pay to that particular metric, black being the most worrisome, green tending to mean less worrisome. So first off, we give you a CVSS score associated with that vulnerability. This particular vulnerability gets a score of 10 according to the CVSS 2.0 scoring scheme. We also maintain the CVSS 3.0 scoring scheme as well, but clearly this is a legacy vulnerability which was scored according to the old CVSS scheme. And in this particular case, this vulnerability gets a score of 10, which indicates the most worrisome type of vulnerability. Moving on, we've got a comment about where a potential abuser would need to be if they wanted to try and exploit this vulnerability. In this particular case, this vulnerability, you only need remote access to the software to try and exploit this vulnerability. So in other words, you just need a network connection, which inherently means there's probably a larger attack surface or footprint that means more abusers or attackers can try and exploit this vulnerability. If the location was physical, then that would indicate that you needed to be physically sat at the machine running this piece of software to try and abuse this vulnerability, which inherently you would expect give you some additional protection from this particular vulnerability, because you know that the machine, for example, might be running in a locked room and people can't access it. Okay. Moving on, we've got whether the steps for taking advantage of this exploit are in the public domain or not. And if those steps are in the public domain, then clearly you should be much more worried about this particular vulnerability. Whereas if the steps haven't been publicized, then you've probably got a much more greater sense of confidence that you won't find this vulnerability being exploited. Of course, if the steps for the vulnerability, it's not known whether they're in the public domain, then that's an unknown, and unknowns are always a little bit more worrying. You've got to probably protect yourself against such vulnerabilities simply because you can't be sure one way or the other. And then finally, we've got what remediation steps you can take to protect yourself against this vulnerability. In the majority of cases, the remediation is to upgrade your dependency to a newer version of that particular component. In the forthcoming release of CodeSentry, we'll have some additional metrics which you'll be able to use to assess whether you should be concerned about vulnerabilities, such as whether the vulnerability is on the known exploited vulnerability list or not. Clearly, if a vulnerability is known to have been exploited, then you should be probably more worried because it seems that it's being taken advantage out in the wild. And we've got some other key new metrics which you can use to help assess and prioritize how you should go about remediating or reporting vulnerabilities. Just like we could annotate the components in our report, we can also annotate our vulnerabilities as well. And we can say whether we don't care, or we fixed it, or it's under investigation. We can have some comments. We can potentially modify the CVSS score if we so choose, and then if we do that, modify some, or sorry, apply some comments why we believe to explain why we've altered the CVSS score. Okay, so I've ran through the critical path of interpreting the results for a binary composition analysis scan here. One of the important things is obviously producing the reports, which are those bill of materials, which we were talking about during the presentation. And as you can see, by hovering over these buttons here, we can produce either Cyclone DX or SPDX format bill of materials, which will also include any of the annotations which we talked about, whether a component should have been included or not, and those comments. Both of those formats are just JSON formatted file types. We can also separately produce a vulnerability report which focuses just on the detected vulnerabilities, and again, what annotations and mitigations and comments you may have attached to each of those vulnerabilities as well. We can produce the old favourite CSV format file as well, and for something more human consumable, we can also produce PDF reports, which is basically including many of the views which I've shown you up to now during my presentation. Those views are just incorporated optionally, as you can see, into those PDFs. So if I just move along and highlight a couple of other capabilities here. First off, we have a CodeSentry instance dashboard, which is giving some overall metrics across the combined scan data. And rather usefully, all of these charts are interactive. So this chart down here is showing me all of the critical vulnerabilities, for example, across all of my scans that we had a low confidence about. Whereas this particular field here, for example, is telling me about the 14 critical vulnerabilities that exists in the scans in my instance somewhere that have a status of direct. We didn't talk about direct or definite statuses, sorry. We only talked about low, medium and high confidence. What is a definite status? Well, for example, if you were scanning a JavaScript binary, for example, one of the mechanisms we use to extract dependency information in that space is by scanning of the JavaScript manifest file, which is inherently a source of truth. So any components that we find through that mechanism of scanning JavaScript binaries, for example, would have a definite match status. The direct status, on the other hand, refers to components that you may have manually added to your bill of materials. There may be things that our binary composition analysis scan missed, or your bill of materials that you wish to produce may also need to include non-software information, such as hardware, for example, or other software that you rely on. So to that end, you can go to this list and you can search for things of value which you need to mention. So I could look for the Chrome browser, for example, if this was part of your deployed solution, and then find a particular known version of Chrome. And then I could go and I won't do it here, but I could add that component to my scan targets, and CodeSentry automatically knows what the components and therefore the vulnerabilities are that exist within that version of Chrome, and that would be matched up with those definite component results which I mentioned about in the dashboard summary. But I could click on this link here and it would immediately take me through to the various scans which contain the components that had those definitely known problematic components within them. And this takes me on briefly to one more key feature I think I can squeeze in just before the end. CodeSentry's vulnerability database is constantly updated. Okay, so whenever you conduct a scan, if you were to come back to that scan in 6 months' time or 12 months or some point in the future and requested the bill of materials for it, you automatically would get a bill of materials or a report, whichever one it is, which incorporates all of the vulnerabilities which were originally found, but also the new vulnerabilities which have been discovered in those components since the scan was conducted. And actually on this page here, you've got an interesting way of being able to query what the new vulnerabilities might have been. So for instance, I could say, please just show me what the new vulnerabilities were in any of these scans since 2024 of June. We'll pick the 1st of June here. And I'll look for updated exploit information as well. And in this particular case for these scans, there was no new vulnerabilities that have been reported. But I'm sure you appreciate what the capability was that I was trying to demonstrate there. So I'll conclude my CodeSentry presentation there, because we are running short of time. I just want to move on to my final couple of slides here and just point out that if you've been interested by what you've seen here today, then obviously there's easy ways to try CodeSentry through the SaaS service, for example, but also we have a free SBOM offer which you can take up by contacting ISIT afterwards to take advantage of. Other than that, thank you very much for listening, and if there's any questions, please do ask.
Thank you, Rob. Effectively, we have some questions. Avant de passer par contre aux questions et aux réponses, je souhaite juste complémenter ce que vient de dire Rob. Tous les participants à ce webinaire, vous avez la possibilité, et veuillez nous contacter pour cela directement, d'avoir une analyse sur une application exemple, donc de générer une SBOM à travers ce webinaire. Et également, à la fin de ce webinaire, vous allez recevoir un petit sondage. C'est juste quelques questions qui nous permettent de faire évoluer nos événements. Donc, je vous remercie par avance d'y répondre. C'est vraiment très utile pour nous. Donc, on va passer aux questions que nous avons reçues. So, Rob, the first question we have is during the presentation of CodeSentry, one question about CodeSentry. Is CodeSentry able to detect transitive dependencies? That means if a component itself depends on another component, can CodeSentry be able to detect both?
Yes, it is the answer. So obviously during the development of any of these components, for example, they may have themselves utilized other open source components. So there's a dependency tree. And clearly there will be diminishing evidence as you look down the dependency tree of anything that these components used. But as long as there is enough remaining evidence in the target which is being scanned, then CodeSentry is able to find both libxml2, for example, and the dependencies that were used during the development of libxml2 as well.
Okay, thank you. Another question. During the presentation, you have spoken about different languages supported by CodeSentry. do you also manage C and C++?
Well, yes, that was the compiled binaries that I referred to. Yes, yes is the short answer.
Thank you. So yeah, we are close to the end of the webinar. Maybe another question out. How long does it take to scan a complete module like Camtasia, for example?
You're probably looking at, yes, so in this, when I conducted this particular scan, we had a scan creation date, and rather nicely, upon completion of a scan now, you will be sent an email. And so from that you can understand and calculate what the amount of time is. It's not a hard and fast answer I can give you. The best way I can probably answer it is that CodeSentry will scan something like 10 targets per minute. So you can imagine if an archive had 100 binaries within it, so 100 executables or 100 DLLs, for example, then that would be 10 minutes. So that's probably a better way of quantifying and understanding how long CodeSentry takes. 10 targets per minute can be scanned.
Okay, thank you. Maybe the last one. Can CodeSentry detect the operating system? I mean, if it is a part of the artifact that it is scanned.
Yes, so that was one of the scan types here. So I'm guessing the idea behind this question is that maybe you don't just deploy your software in isolation, but maybe you deploy your software along with the operating system as well. We certainly have customers that do follow that deployment approach. And in that case, there is a definite interest to understand not just the components and the vulnerabilities due to the software, but also the operating system on which it is running. And if I just briefly scroll down here to this particular view here, we can see for this scan which was conducted here, we can see that the version of Windows which was embedded in the artifact which was scanned has been detected. And we don't just tell you it's Windows 10, we tell you down to the patch release of Windows which is detected. We'll be able to have an equivalent ability for Linux in the next CodeSentry release if Linux is bundled in your distribution, and other operating systems as we support them. As you can see, we don't just report the exact patch release of the operating system. We'll also comment on the software packages which were deployed with the operating system as well, because they themselves would be interesting to understand if they have any vulnerabilities and whether steps need to be taken to protect against them as well.
Thank you, Rob. I guess regarding we are running over the time, we will conclude, so I will switch into French again. Merci à tous pour avoir suivi ce webinaire. J'espère qu'il aura répondu à vos attentes.